Hello everyone and welcome back to Jack's Labs. Today we have the Series Circuits Lab, which is a continuation of our Conductive Plato lab that we had last week. But first, before we get into the procedures, let's go over some key terms and vocabulary. Our first term that we're going to be going over is current. Current is the flow of charged particles, such as electrons or ions, that move through an electrical conductor. Next is a series circuit, which is what we're creating today. All of the components in a series circuit are connected end to end to form a single path for current flow. Next is voltage. Voltage is the electromotive force, or the pressure in quotes, that pushes electricity. And then finally, Ohm's law. Ohm's law is a law that states that electric current is proportional to voltage and inversely proportional to resistance. And the formula to solve it is V, which is voltage, equals I, which is current, times R, which is resistance. Now that we've gone over the key vocabulary terms, let's get into today's lab. Let's go over first the materials. The materials you'll need is conductive Plato, non-conductive Plato, 3 battery packs with AA batteries, LED string lights, a multimeter, and scissors. The conductive Plato and non-conductive Plato tutorials to make can be found in our previous video. The independent variable of this is the amount of LEDs in the circuit, and the dependent variable is the brightness or the voltage of the LEDs in the circuit. The control is the non-conductive Plato, and the constants include the environment, the battery packs, the type of batteries, type of LEDs, multimeter brand, and then the Plato used, which is the ingredients in the Plato. So on to the procedures. First, you're going to gather those materials. Next, you're going to create the battery pack arrangement that we created in our previous video, so now we can test the associated voltages. So for our first circuit, we're going to take 2 of the conductive Plato balls and we're going to line them up next to each other, and we're going to connect one end of the battery pack circuit into one end and then the other one into the other Plato ball. Once we do that, we're going to take an LED light and we're going to stick it in the middle of our 2 Plato balls. It should light up. If it doesn't, play with the wires on the LED. Make sure only one wire of the LED is going in to create the path of least resistance. And if you get it right, the LED should light up. Next, take your multimeter and plug in both of the prods into each Plato ball to see how much voltage you are creating with the battery packs. This voltage is contributing to the light in the LED. So we're going to do a couple different arrangements similarly to this first one. So this next one, we're going to take 3 Plato balls instead of 2, and we're going to have an extra LED light. So we're going to have 2 LED lights this time. And you can see the different voltages associated with plugging the 2 prods into the first 2 balls and then the second 2 balls, and seeing how much the difference is between how much voltage is going into the first LED and how much voltage is going into the second LED. And then this third arrangement, we're going to do the same thing except with 4 different conductive Plato balls and 3 LEDs. So we're going to create that circuit again, and we're going to see the different voltages associated with each LED as they get deeper into the circuit. To show why they each need to be connected, we'll open up this middle light and you'll see that there's no power going to any LED because the circuit is open and not closed. If it's not a closed circuit, then the LEDs will not turn on. You can then repeat each of those experiments with your non-conductive Plato and find that the LEDs completely will not turn on, nor will any voltage be associated because the Plato is unable to carry a current. Once you've done all that and tested each voltage, the lab is complete. I hope you guys enjoyed this series circuit lab, and I'll see you in the next video.